We need to know about the construction materials like walls, windows. Windows indicates glass also. Doors, partitions, floor, ceiling and roof. इसमें आप इसमें you need to know about dimensions, construction material, dimensions, construction material already. So ये चीज हमें पता करना पड़ेगा पहले, हमें लोड कैलकुलेशंस करने से पहले. ओके, नेक्स्ट यू नीड टू नो अबाउट internal loads like people, lighting, appliances. People, lighting and appliances. ये चीज भी हमको पता करना पड़ेगा. नेक्स्ट, सो रेफरेंस ड्राइंग से आपको मिलना है डायमेंशंस लाइक लेंथ, width or height of the building. So you need to know all these things. Okay. And finally, one more point, you need to know about the application of the project. Application of the project. Okay. ये पूरा चीज हमको पता करना पड़ेगा. Clear? Make a note of this. Make a note.
If from Hyderabad, Delhi.
Hello. Done.
Yes, sir, done.
Okay. One minute. Just allow me 1 minute. The next concept is load calculations. Okay. Coming to the load calculations. In this load calculations, we are going to calculate the room sensible heat as well as the room latent heat as well as uh, total heat, TR, ESHF and ADP as well as CFM, total CFM. So ये पूरा चीज हमें इसमें फाइंड आउट करते हैं. So now, so what is the major source? Sorry, heat loss equation. What is heat loss equation? Q equals to A into U into delta T is the formula. Q equals to A into U into delta T. Okay. Q equals to A into U into delta T is the formula. Now, what is Q? Q is heat gain in terms of BTU per hour. Heat gain in terms of BTU per hour. Next, what is A? Area in square feet. A equals to area in square feet. And what is U? U equals to coefficient of heat transfer. U equals to coefficient of heat transfer. Okay. So these are the different. This is the heat gain Q BTU per hour equals to A into U into delta T. Now, so what is U factor? U factor is the transmission coefficient of U value is measured as the rate of heat travel through a material. Okay, it is the rate of heat travels through a material. एक material से कितना heat travel होता है, that is called as U value. So walls and roofs are typically consist of multi-layer with different materials. Okay, 1 minute. Okay, walls and roof, every material, see, basically u value is nothing but it is inversely proportional to the resistance. So will all the materials have same resistance, sir? Will all the materials have same resistance?
No, sir.
So every material has its own resistance according to the material type, right? Same here,
Right, sir.
the U factor also depends on the resistance, and U factor also may vary according to the U factor also may vary according to the material type. Okay, next. So the U factor for specific wall or a roof is calculated by summing the thermal resistance, all the resistance values, okay, and then taking it reverse. U equals to 1 by R. Basically, U equals to 1 by R. Now, so these are the cooling load components. Actually, in the first class, we have discussed the heat in the room. From where the maximum source of heat? The maximum source of heat is from sun. Okay, so this heat, how it travels to the room? It travels from the roof, it travels from the glass, it may be traveling from the exterior walls, or it may be from the ceiling, partitions, and there are some internal heat which comes from light, people, and equipment. Okay, there are many sources of heat, and this heat travels from outside to inside through different materials. Okay, so we are going to calculate now. We are going to calculate all the materials. Okay, we are going to calculate the heat travel through all the different materials, and we'll identify total how much heat, okay, how much heat is generated in the room. Okay, now, so this is the project. Okay, this is the project we have. I'll share this project through WhatsApp. Okay, so this is the project. It is flat one, and this is flat two. Okay, one is flat one and one is flat two. Now it is in second floor. Now this is in एक G+2 project है ये ground floor है, ये first floor है, and this is second floor. Okay, so now this is in the second floor. Okay, this is in the second floor, and we are working for flat one. Clear till now?
Yes, sir.
Okay. Now, so considerations. The architect has given some considerations. Window size, take it as 4 feet by 3 feet. Window size हमें 4 feet by 3 feet लेना है. और door size 7 feet by 3 feet. Door size is 7 feet by 3 feet. And floor to ceiling, floor to floor or floor to ceiling, you need to consider it as 12 feet. Floor to floor or floor to ceiling, you need to consider it as 12 feet. Okay, so these are the considerations we got from the architect. Now So now project details, project name. So now who has given the project? That project name will write. If Lodha Constructions has given the project, will write Lodha Constructions. If Aparna Constructions has given the project, will write Aparna Constructions. So who has given the project? That project name will write. Later location, which location that project belongs to. Okay, which location that project belongs to, will mention the location. Later, we need to mention the client name who has given you the project. कोई आदमी तो देता है ना, some person only will give project, right? That contact person name, client name. And which floor we are working? We are working for the second floor. Okay, now we are working for the second floor. Space used for. So in the space used for, I'm working for this master bedroom now. I'm working for this master bedroom. As I am working for this master bedroom, okay, as I am working for this master bedroom, you can look the dimensions of this master bedroom: 12 feet 2 inch into 10 feet 5 inch. Okay, 12 feet 2 inch into 10 feet 5 inch. So 12 feet 12.16 फीट हो गया है. ये कैसा लिया हमें? 12 फीट 2 इंच है ना, 12 फीट 2 इंच है. इसको हमें फीट में ही कन्वर्ट कर दिया. कैसा कन्वर्ट किया? 12 फीट, एक फीट में कितना इंच होता है? 1 फीट हैज हाउ मेनी इंचेस?
12 inches.
12 inches. So 2 divided by 12. How much will you get? 12.16 feet. Same like that only. 10 plus 10 feet 5, 10 feet 5 inch. 10 plus 5 divided by 12, 10.41 feet. So which is 126.58 square feet. Okay, so this is how you need to you need to write the project details. Is it clear?
Clear, sir.
Okay. So this is load calculation sheet. Okay, this is load calculation sheet. In the load calculation sheet, this load calculations is also called as E20 calculations. This is also called as E20 calculations. So why this is called as E? What do you mean by E? Can you tell me? Is there anything for E20?
This may be total 20 calculations will be there.
Yeah, E indicates estimate. E indicates estimate, and 20 indicates 20 calculations we are going to do. Okay, estimate 20. E20 indicates estimate 20. Okay, so now, so this is outside ambient conditions. So I'll share you, please allow me 1 minute, sir. I'll share you one document with you. Now I have shared you one sheet in the WhatsApp. Okay, that sheet. So now here what we need to define. So we need to define the outside conditions. See this. So the ambient conditions. So to define the ambient conditions, okay, to define the ambient conditions. So first outside conditions we need to find out from the data. So from page number, okay, from page number 3, I think so. So from page number 3, once if you open the file which I have shared you, yes, from page number 3, so you can see from page number 3. So page number 3, what it is defining outside design conditions. Hyderabad, here we have Hyderabad. Hyderabad ka summer temperature is 106, 78 and 28. Okay, so here Hyderabad ka summer temperature 106, 78 and 28. See, dry bulb temperature is 106, wet bulb temperature is 78, relative humidity is 28. Okay, what are the ambient conditions as per ASHRAE? Comfort conditions. What are the comfort conditions as per ASHRAE? As per ASHRAE, the comfort conditions are, okay, the comfort conditions are dry bulb temperature is 75 Fahrenheit and relative humidity is 50%. Dry bulb temperature is 75 Fahrenheit and relative humidity is 50%. Okay, is it clear?
Clear, sir.
So, after finding out the values from the psychometric chart, we'll get like this. So, dry bulb temperature is 106, wet bulb temperature 78, relative humidity is 20, dew point temperature is 65, and HR, this is HR is 100. For the room, 75, 63, 50, 55, and 65. So, already this class we did. You can see if you missed this class, how to find out these values, the first recording session will be this class only. Okay, next the difference is 106 minus 75, which is 31 Fahrenheit, and difference in humidity ratio is 35 degree Fahrenheit. Sorry, 35 grains per pound. Okay. Make a note from here. Once it is done, tell me, I'll change the slide. Sir, load calculations are most important to become a design engineer. Please make a note very clearly. I request. No screenshots. Make a note point to point. So this will be useful throughout your life. Once it is done, please raise your hand. I'll change the slide.
Done, sir.
Done.
Done. Done, sir. Done, sir. Done, sir.
Make note of this word, this table from page number 3.
Sir, what are the comfort conditions as per ISRE?
Same.
Done, sir. Sir, why we are taking only dry bulb and this wet dew point difference only?
So that it will come. You wait. In the further, you'll identify it.
Done, sir.
One minute. First concept, solar heat gain through glass. Okay, the first concept is solar heat gain through glass. So in this image, you are able to see the directions. I'll give the directions. Just to mention the directions in your book. This is north and this is east. Okay, this is north and this is east. Okay. So in the following image, glass will be located in window. Glass कहाँ पर होता है? Basically, glass will be located in the window only. So where the window is located? So this is the window and this is the window. Two windows we have for this master bedroom, right? Okay, we have two windows for master bedroom. Which window we need to consider? Either this window or this window. This is solar heat gain through glass. What do you mean by solar heat gain through glass? The heat comes from the sun which is exposed to glass. Sorry, the heat coming from the sun when the glass is exposing to the sun. Here in these two windows, which glass is exposing?
Right side.
This one?
Right one.
Yes, sir.
East.
This one? Yes, east one. East one is exposing. And this north one is not exposing. Why? Because it is in balcony, it is in corridor. Okay. So we consider for the east. So we have two windows, one is in the north and one is in the east. We only consider east window in this calculations as it is exposed to sun. So Q equals to A into U into delta T. Here area of glass equals to 12 square feet. Starting में बोला है ना, we have told in the considerations, we told you that the size of the window is 4 feet by 3 feet. So as the size of window is equals to size of the glass. So that is the reason 12 square feet we have taken. Next, A equals to 12 square feet, and we need to go with specification of the glass. Glass is made of ordinary glass with inside Venetian blend of medium color. Glass is made of ordinary glass with inside Venetian blend of medium color. So allow me 1 minute, sir. I think we have opened something wrong PPT. So glass is made of ordinary glass with inside Venetian blend of medium color. Okay, so from page number 12, if you see from page number 12, it is made of ordinary glass. You can see the ordinary glass here. You can see ordinary glass here.
Yes, sir.
Okay, with inside Venetian blend of medium color. Medium color is here. So U factor is 0.65. U factor is 0.65. Next, change in temperature. To find the delta T, to find the change in temperature, we need to find the latitude range from page number 3. Okay, page number 3, if you open the page number 3, here, so Hyderabad ka latitude range कितना है? What is the latitude range we have here? 17.86 degree north. 17.86 degree north we have here. So as this is 17.86 degree north, we consider it as 20 degree north. We'll go to the nearest round of value. So from page number 16, so you can see the page number 16. If I come again, I'll show here in the bigger screen, you can understand. So from page number 16, 16, solar heat gain through ordinary glass, 20 degree north, 20 degree north latitude. Clear? Now we are going to calculate the load calculations on the peak values. Okay, highest value हमें find out करना पड़ेगा. So if your machine is capable of holding the load on the peak day, will your machine able to work remaining all the days? Yes or no?
Yes, sir.
If your machine is capable of holding the load on the peak day, then your machine is capable of holding the load throughout the year. So we calculate on the peak day. For India, the peak day is May 21. In India, the peak day is May 21, and we go at 4 p.m. The design temperature is 3 p.m. or 4 p.m. You can take either 3 p.m. or 4 p.m. Design temperature is always 3 p.m. 4 p.m. के बीच में ही होता है. So I am considering it as 4 p.m. East side, it is 12 BTU per hour. It is 12 BTU per hour east side. West side it is 163 BTU per hour. North side it is 23 BTU per hour, and south side it is 12 BTU per hour. So each side 12 BTU per hour, west side 163, north side 23, and south side 12. So we are working for east side, right? We are working for the east side. So we consider 12 BTU per hour. Therefore, Q BTU per hour equals to A into U into delta T, where A is 12, delta T is 12, and Q equals to 0.65, which is 93.6 BTU per hour. This is the solar heat gain through glass. Glass से इतना heat आ रहा है. ठीक है. Hope you are clear, right? Say yes if it is clear. Okay. Make a note. Once done, please let me know.
चपाती आलू टमाटर करी चाहिए
Done, sir. Done, sir. Done, sir. Done, sir. Done, sir.
Next, solar and trans gain through walls and roof. Okay, so in this layout again, the wall is exposed to towards the east direction. Again, a wall east direction. Wall means walls are always exposed to sun, sir. ये wall होता है. This is wall, and this is partition. The internal boundaries are partitions. The external boundaries are walls. Okay, so ये रूम पे सिर्फ ये मास्टर बेडरूम को ये वॉल होता है, एंड दिस इज ईस्ट डायरेक्शन. दिस इज इन ईस्ट डायरेक्शन. ओके, सो ग्रॉस एरिया wall area equals to length into height. Length is 12.16 feet and height is 12 feet, right? This is length 12.16 and we have considered the height from floor to ceiling is 12 feet, so which is 145.92 square feet. So net area equals to gross area minus area of window. Net area equals to gross area minus area of window. So therefore 145.92 square feet minus 12 square feet, which is 133.92 square feet. So this is the area of wall. Next, we need to consider U factor. So specification of wall. So who will give the specification? The wall specification was provided by the architect. Architect need to provide the specification of the wall. Wall is made of hollow concrete block with a mixture of sand and gravel aggregate of 8-inch thickness and 3 by 8-inch plastron walls with a mixture of lightweight aggregate. Wall is made of hollow concrete block with a mixture of sand and gravel aggregate of 8-inch thickness and 3 by 8-inch plastron walls with a mixture of lightweight aggregate. Therefore, so from page number 5, if we come to the page number 5, wall is made of hollow concrete block, okay, with a mixture of sand and gravel aggregate of 8-inch thickness and 3 by 8-inch plastron walls, okay, so which is 0.43 BTU per hour per square feet into degree Fahrenheit, okay. And weight of the wall, if you see the weight of the wall here, 8 inch का बगल में, after 8 inch, what is the value it is there?
53.
53. So that 53 represents the weight of the wall. That 53 represents the weight of the wall. So if see here, thickness in inches and weight pounds per square feet. Thickness in inches and weight pounds per square feet. Now, this 53 pounds per square feet is used to find out the delta T. Now coming to the delta T, equivalent temperature difference. In this case, for wall and roof, sir, you need to remember, for wall and roof, equivalent temperature difference delta T is equals to, okay, delta T is equals to T1 plus T2. T1 plus T2. Therefore, T1 is equivalent temperature difference. T1 is equivalent temperature difference and T2 is correction factor to equivalent temperature difference. T1 is equivalent temperature difference and T2 is correction factor to equivalent temperature difference. So now, weight of the wall is 53 pounds per square feet, which we consider around 60 pounds per square feet. We consider as a 60 pounds per square feet. Okay. So, as it is 60 pounds per square feet, now at 4 p.m. same east side at 4 p.m. is 12 degree Fahrenheit. West side it is again 26 degree Fahrenheit. North side it is again 10 degree Fahrenheit, and south side it is again 26 degree Fahrenheit. So this is a T1 value. This is T1 value, equivalent temperature difference. Next, T2, correction factor find out karna. So to find the T2, we need to find out the daily range. To find the correction factor to equivalent temperature difference, we need to have two factors. One is a daily range. From page number 3, you are able to see the daily range here. For Hyderabad location, daily range is 14 degree Fahrenheit. For Hyderabad location, daily range is 14 degree Fahrenheit. Okay, now next one we need design temperature difference. Design temperature difference means outside dry bulb temperature minus inside dry bulb temperature. So coming to 106 outside dry bulb temperature and 75 inside dry bulb temperature, which is equals to 31 degree Fahrenheit. Okay, which is equals to 31 degree Fahrenheit. Therefore, from page number 20, from page number 20, we need to find the outside design temperature. Outside design temperature कितना है? 31 है. We have 31, but we have 30 and 35. Let's see, 30 and 35. Now this is daily range. Daily range 14. Come to daily range 14. In daily range 14, 30 ka value is 18. For 30 you have a 18 value. For 35 you have a value 23. 30 का value 18 है, 35 का 23 है. So now 30 or 35. So the difference 30 or 35. 35 minus 30. What is the value? 5 we have, and 23 minus 18. Again 5 we have. So the mean value 5 divided by 5, which is equals to 1. 5 divided by 5, which is equals to 1. So I will be adding 1 in each case. 18 plus 1 19. 19 plus 1 20, 20 plus 1 21, 22, 23. So for 31 degree Fahrenheit, the correction factor is 19 degree Fahrenheit. So as the correction factor is 19 degree Fahrenheit, therefore T equals to T1 plus T2. Delta T equals to T1 plus T2. So for east side, 12 plus 19, which is 31 degree Fahrenheit. For west side, it is 26 plus 19, which is 45 degree Fahrenheit. For north side, it is 10 plus 19, which is 29 degree Fahrenheit. And for south side, it is 26 plus 19, which is 45 degree Fahrenheit. Therefore, Q BTU per hour equals to A into U into delta T, which is 133.90 into 0.43 into 31, which is 1785.15 BTU per hour. Okay. Yeah, make a note. Solar and trans gain through walls.
Done, sir. Done, sir. Done, sir. Done, sir.
రోజు తీసుకొచ్చి తిప్పేస్తారు బయట.
మళ్ళీ ఎందుకు పంపిస్తుంది?
మళ్ళీ ఆన్లైన్లో మళ్ళీ పార్టీ మాట్లాడింది పైన ఆవిడ.
Done, sir.